Alright, Einstein's failure 2. Show me the math. Let's get started. Last time we talked about how Einstein and Newton had two very different explanations as to why things fall. Newton said a force pulls the apple down to the ground, and he named that force gravity. With that, please keep in mind here that gravity is just a name like Fred or Wilma. So for now we will just refer to it as a force. According to Newton, this force pulls the apple down to the ground. On the other hand, however, Einstein disagreed and said no, the apple is stationary and the curvature of space-time is actually causing the Earth to accelerate upwards to the apple. And since the ground and the apple come closer together in both Newton's view and Einstein's view, Einstein referred to this as his equivalence principle. But as we mentioned last time, the problem with that is the fact that they don't actually equate. While both the ground and the apple come closer together in both scenarios have very different consequences. Now let's take a look at the math. As we know, Newton's second law of motion is force equals mass times acceleration. So when Newton drops an apple, you can take the mass of the apple and times it by its acceleration, and that will tell you how much force it will have when it hits the ground. Now let's flip that around in Einstein's perspective. If the ground is rising up to hit the apple, you take the mass of the entire Earth and times it by its acceleration, and that will tell you how much force the Earth will have when it hits the apple. Since the Earth has way more mass, the Earth will hit the apple with way more force. Herein, Newton's force and Einstein's force do not equate whatsoever. Now, you might say that it isn't the entire Earth, it is just a part of the Earth that is accelerating upward. But if you take just a part of the Earth, then you have the whole Earth dividing asunder and breaking apart in all directions. But that is something we very clearly do not observe. We've had a pretty extensive conversation about this on our debate board. And in it, one globe earther told me, no, it's not the mass of the Earth that you use in the equation. You still use the mass of the apple. In Einstein's view, the force or weight of the apple is still the mass of the apple times the upward acceleration of the Earth. Alright, so let's see where that line of reasoning takes us. Since Einstein claimed that Earth was actually accelerating upward while the apple remained stationary, let's refer to the Earth as a projectile. And the apple, let's refer to that as an obstacle. Now let's go and apply that to our equation. Here, the force would equal the mass of the obstacle times the acceleration of the projectile. By that line of reasoning, if I were to toss an ant as a projectile, and an elephant were to stand in its way as an obstacle, then that ant should hit the elephant with a lot of force because that elephant has a lot of mass. On the flip side, however, that reasoning states if an elephant were to get launched at an ant, that elephant should hit the ant with very little force, because the obstacle in this instance would have very little mass. That is the exact opposite of what we see in reality. So this line of reasoning clearly doesn't work. So that brings us back to force equals the mass of the Earth times the acceleration of the Earth. Which would mean if the Earth is accelerating upward, it should hit every single falling object with the exact same amount of force. Not only that, but when we fall at an accelerating rate, which would mean if it was equivalent and the Earth is accelerating upward, it should be continually going faster and faster. It doesn't matter if you're the size of an elephant or the size of a mosquito. If you get hit by a semi-truck moving fast enough, you're gonna go splat. Therefore, the different amounts of force on both sides should make it more than obvious that Einstein was wrong, because the forces clearly do not equate. Thank you for watching. This video was brought to you by the Flat Earth Institute of Science. And we highly recommend that you check out the Flat Earth Clock app, where you can get to know a flat earther near you.